Hello all. Today we will start with trees. So first let me explain what is the application, why we are using trees, because there are a lot of other data structures also, like stacks, we have queues, and then we have linked list. But why we are using trees? So basically, if you consider an array, okay, if we consider an array, so what happened, you know, right? In this particular array, if we have multiple what we say slots, okay. So if we are for example, there is a program we have to build to store like many phone numbers, okay. So what happens is, if we are storing here a number, for example 821357 dot dot dot, here I am storing some other number 7537 dot dot dot, here some other, here some, okay. So it will go on, and there should be a limitation, you know, right? In arrays there is an disadvantage or a con, that it has limited space. Can't exceed from this limited space. So what happens is, there is this disadvantage. But the thing is, the most what we say, the thing is which is disturbing in arrays is in the case of traversal or searching, okay, or traversal. What happens is, if I want to find any one number, for example it is situated in 50th row, okay, 50th cell, so I need to check from here, I need to check right here, then I have to check if it is this, if it is this. So as per, we know that it actually has a big order of O raised to 1. So actually this thing consumes lot of time, you know, right? It actually consumes a lot of time. So that's why there is an effective method which is trees, and we will gonna learn that. So we know, right, like what is trees basically. So first I will let you know what is trees, how it looks. So for example, let us suppose we are taking the same you know, the problem which we had, the storing the phone number, okay. So we know, right, it our phone numbers in Indian subcontinent, we have this numbers which starts from 600 something, a 10-digit number, to 9 10-digit number. So we have this, right, we know this. So what is the what we say, so it is in between this only, it is not for no normal range, it has to be in this between range. So what we'll do is, we will take a number which will start from 800 dot dot 10-digit number. Now what happens is, how we are going to store the next number. We will gonna store it like this. If we are getting a number which is smaller than this node, the first node, we will store it here in the left side corner, okay. For example, if it is 765 dot 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 something, then we know that it is less than 8 this number, so it will store, we will store it here 765, okay. If it is more than 8, if it is for example 8651, so it is more than 800, so we will store it here in this, okay. Again, if we are getting some number has 779, okay, so how we will do this? How we'll do this? We will do, see, it is obviously less than the root node, right? So it is going here, we know that. But what about here? Now this is the condition. If we are taking this condition, it is greater than this number. This whole number 779 dot 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 is greater than this number. So it is obviously going here, right? So we will store it here, okay. This sort of application, this sort of thing is very useful while traversing, and we will explaining that. The thing is, in which was con in array has been here faster, which is traversing speed is faster here, okay. Because while we are searching something, even if in case we are searching 865 dot dot dot. So we know from here itself, from the root node itself, right? So we will obviously go in this side. So the 50% of this whole population is neglected, and we are searching in this whole subtree, right? So this is good while we are searching or sorting, and we will learn about the complexities later on. Okay, so now we will start with the structure of trees. So here this is a structure you can see, right? So when I'm saying the root node, so what it implies is this: the very first node is the root node, right? This we will call as root node. Okay, so in any tree, the very first node which you see, it's the root node. Okay, so what is next? It is a child node. So what is child node is, see, for example, if you see, like if this is a node and there is a arising two another nodes, so these two other nodes are called child nodes. Okay, simple. So this is the parent node, right? Yeah, we can say that, yeah, parent node. Okay, so here which are the child nodes? See, if this we consider as A, B, C, D, E, F, G. Okay, so A child nodes are B and C, B's child nodes are D and E, C child nodes are F and G. Okay, we can say like that. Okay, so these two are done. Siblings. See here, for mother or a parent B, there are two children. So D and E are siblings. Okay, so this is done. What are leaf nodes? Okay, so you have to remember this: nodes which do not have child node are leaf node. So here, which nodes you will see, like they have no child node. See here, this and this. These four you can see, like there are no child nodes, right? There are no child nodes. There are nothing here. Okay, so these four are leaf nodes. Okay, get it. So next we will look upon what are the structures. Okay, so we can see here, this is the actual inner structure. Now we are representing the tree like this, but in actual it is like this. So if we are saying this is a root node, right? So what is this tree slots? This is for the value. Okay, so whatever we see, the phone number structure, if you are putting any number or any value, it will go inside this middle slot. So what is this for? These are actually for the pointers. Now why pointers is needed here? See, we have the left child, right? Left child and right child. So the address of these things of the parent node is stored here. So in left side, it is storing the left child address, so it is stored as the pointer, and in here also the right child will be stored as the pointer. So in this way it will be doing. So the thing is, here what happens when it is a leaf node? So here there is no no child node, so we can say it is null here. The pointer shows null because there is no child node. Okay, this way it is done. So what are the advantages of using trees? Trees are actually in hierarchical approach. You can see like all the nodes are in the hierarchical form, so it is easy for to manage insertion, deletion and all those stuff. Okay, and here also in what we see in the arrays, we had upper limit, right? There is a fixed we have to have a fixed amount of number. There is a fixed number, right? But in trees we can have as many as child nodes, so there is no limitation. so there is no upper bound here. Quicker search and access, yeah, we can see like if here if it is 8,000 or something, we had some 7,000 any number if we need to search, so it is neglecting this whole thing, right? The decision is quite made here itself in the root node that the number this is exiting in this side, the left side. So this is very quick, so that's why quicker search and access. Okay, and the next is the moderate insertion and deletion. Yeah, because see in array wala case we had some of the cons, because even in case I need to insert a number in between here, right? In this and this corner in between I need to insert, then there is a lot more process. We have to shift all this and we have to insert here everything. This is quite a little tough side, or it actually takes more time complexity, but here it is pretty well managed. Even deletion part also is managed well, so we will be looking at this in the code section. So has this much for this video.